Okay, in this video we're going to cover simple experiments. Again, those experiments that have one independent variable and a dependent variable that you're trying to predict. So I'm going to return to this fake data set that we'd been using earlier in the semester, and I want to remind you that in this data set we have 60 participants. They're male or female. This variable here is coded such that male equals 0, females equal 1. Of a variable here that corresponds to the family's income, the mom's level of education. And if you ever forget what the coding scheme is, you can go in here under the variable view, and you can see that 1 equals high school, 2 is that the mother had gone to college, and 3 is that they had some graduate training. Then we have a code for that as well that we created last time, where 0 is high school and 1 is anything college or more. And then 3 time points at which we hypothetically, supposedly, took vocabulary measures of the participants. So we have these 60 participants. We find them at 18 months old, 24 months old, and again see them, that same person again at 36 months old, and we basically assess what the vocabulary is in terms of number of words. Okay, so what we can see is that there are some within subjects variables. For instance, time point. We get vocabulary measured within the same participant at multiple time points. So that's a repeated measures within subjects, however you want to describe that. And then there are some between subjects factors. For instance, gender. Participants are either male or they're female. They have a mother who has a high school degree only or some graduate training, but that's between subjects. No one subject has both of those things. We have the between subject factor of income. Okay, so one of the maybe simplest questions that we could ask is a t-test question, and there are both between subjects and within subjects t-tests. So let's go through a between subjects t-test first. One simple example would be to see whether or not there is a vocabulary difference between boys and girls in this data set at, let's say, 18 months. We could do this at 24 months or 36 months, but for this first example, we'll just see whether or not boys and girls differ in terms of their vocabulary at 18 months. So to do that, we go to Analyze and Compare Means. And the first thing I want to do, actually, there's a way to do this within the t-test that I'm going to show you, but I just want to generate some means because I think it's useful for us to just kind of look at those and see what we're dealing with. We always want to inspect the data first. So here, I've clicked on means, and for the, I want to get means depending on gender for vocabulary at 18 months. And here we can see that 31 of our participants are male, 29 are female, and the vocabulary is slightly higher, 15.655 for females compared to males, 11.322. All right, and the standard deviation information is here. And this information tells us that girls in this data, girls at a year and a half or 18 months have a higher vocabulary than boys. But we want to know whether or not that is a statistically significant difference. Is this just a difference that we see here, or is this a meaningful difference such that it's unlikely that males and females actually have the same vocabulary, but rather that there is something about gender that's causing this difference, that corresponds to this difference. And so what we can do is go to Compare Means, and we have to choose what kind of test this is. So is this a one sample t-test, an independent sample t-test, or a paired t-test? One sample t-test, recall, are from your stats class, is when we compare one number, the sample mean, let's say, to a set number, let's say something like 0, and we want to see if the average for the sample is different from 0. An independent samples t-test is the same thing as a between samples t-test or between subjects t-test, and that's the one that we're going to use here. And a paired samples t-test we'll talk about in a bit, but this is the kind of t-test that you use when you have a repeated measures design. Okay, so we'll go to independent samples t-test. That's SPSS language for between subjects. And I'm going to put in gender code as my grouping variable. wants to have some sort of numeric value here. So I'm going to say 0 and 1 are the codes that we used, and vocabulary at 18 months is the dependent variable. Okay, I clicked on options to see if there was anything we wanted to ask for there, but we don't. I'm going to go ahead and click OK. And so within here, as I alluded to earlier, when you run a t-test, it gives you these means. So you'll see that these means are the same ones here, except for they're coded 0 equals male. And so the score here, 15.6552, which is the same one here, appears on that appears lower than it does in this table, because this is in alphabetical order. Okay, so these are the same means. The t-test is given to you here. You get this information, which is a statistical test that doesn't compare the means that you're interested in comparing, but rather tells you whether or not there's equal variance in your conditions. And for this purposes of this class, we're just going to ignore this. So you should not report this for your assignments. Instead, we're going to look at this part of the table from this t-statistic and on. All right? And so we can either assume equal variances or not assume them. Here we see that this is not a significant test. So in general, we'll just use this top one. We will assume that variances are equal. So in order to write up this result, you will use this part of the table here. So what does this tell us? This tells us that the p-value is less than 0.05, which is usually our cutoff. And that tells us that these two values, 11.32 and 15.66 rounded, are statistically different. Means it's unlikely that these two numbers, that the true value of these two numbers is equal, but rather that there is probably a significant difference between these numbers. Okay? And this is our degree of freedom. So let's write this up. So I want to give you a sample of how we would write this up. I'm going to pull up my Word document here, and I'm going to overlay it like this so I can type and see. So when we write up t-test, we want to say something about what was done. We compared the vocabulary of boys and girls at 18 months of age. Boys and observed a statistically significant difference. And then here is where we type the statistics. So we do a comma, space, italicized test statistics. So the test statistics get italicized unless you're using beta values or something like that. Those don't need to be italicized. But here, this is a T, so we do. 58 degrees of freedom is what we have. We can see that on our table. It's n-2 in a t-test. We lose a degree of freedom to estimating one mean and a second degree of freedom to estimating the second mean, because we have these two groups, equals negative 4.32. P, which we italicize, equals, and here we have a p-value that actually reads as 0, but we never report it that way. We always say that p is less than 0.001. So if your table says zeros, we report it as p is less than 0.001. This is the only case. Otherwise, you report the p-value rounded to 2 decimals exactly as it's presented in the table, except for the case in which significance level reads as 0, in which case you type this. Okay? And then we want a plain English sentence. So we say, we compared vocabulary of boys and girls at 18 months of age and observed a statistically significant difference. So what does that mean? We want to be able to describe this to somebody else. So we would say, we need to know what the direction of this difference is. So we see from our means table that girls are the ones who have the higher vocabulary. So we want to say that, right? Girls had a higher, or we could even say girls knew more words at 18 months of age than boys. We could also say girls had a larger vocabulary than boys. Boys had smaller vocabularies than girls. However you want to put that is fine. Then we're going to go back and add in the means. So when we are writing up statistics, for these kinds of statistics where we're comparing cell means or condition means, we want to also report the means of these groups, because that's valuable. It's useful for people to know, well, what was the vocabulary that we're talking about here? So we do that with an italic M, capital, and it's 15.66. I've rounded that. And we also report the standard deviation. So capital SD, italicized, space, equals, space, and then we will type 3.58. Okay? We'll do the same thing here. So I want to be able to tell my participants, or tell my readers, what the vocabulary was of these individuals. So we'll do this. Equals 4.16, like that. Okay? And this is how we write it up. It's very simple. So your write-up should include the test statistic and probability, a description of whether or not it was statistically significant, and a plain English sentence that clearly says what was the difference, if there is one, and the means that were being compared. Now, if this had been the case where this was not statistically significant, we would say we compared the vocabulary of boys and girls at 18 months of age and did not observe, and the effect was not statistically significant. Or we could say there was no evidence of a difference. And then we would say there was no reason to believe that girls knew a different number of words than boys at 18 months. And then we would again populate that with the means of these conditions, or of these two genders. So the write-ups are very similar to what you are familiar with doing before. You use that language of no evidence of a difference instead of saying that there's no difference. Okay? So that is how you write up a t-test for a between subjects t-test. I'm going to go back in here now and talk about a paired samples t-test, which is the language that SPSS uses for repeated measures kind of design, or within subjects t-test. So to do the same thing here, we're going to go to paired samples t-test. And the reason why we have a different test that we choose for independence than paired samples is because the observations all come from the same individual. That means that there's a dependency in your error term, because you're not comparing one person to another person in a different condition. You're comparing one observation for an individual with another observation from the same individual. So your error should conceivably be less, right? One participant should be more similar to themselves than two different participants should be to each other. So that's why we use different tests. So when we do a paired sample t-test, that GUI looks very different. Here you see that you have one pair, and we're going to compare this variable with this variable. So I'm going to look at whether or not there's a difference between 18-month vocabulary and 24-month vocabulary. So what this test will tell us is whether or not between that six more months of development, between being 1.5 years old to 2 years old, whether kids have a difference in terms of their vocabulary. So that's all fine and good, and I'm going to go ahead and click OK. So the outcome is here. So these are the means at time 1, or 18 months. The vocabulary on average, so this is averaging across those boys and girls, so you can see that this number is somewhere between the 11 and the 15 that we saw from the previous test. So we have 13, and we're comparing it to 58. Just looking at those numbers, you can tell that they're quite different, but it's a statistical difference. So here we get the output for this table. We actually, what's nice about SPSS is one of the other things is you get a correlation. So you can see that higher vocabulary at time 18 months correlates positively with higher vocabularies at 24 months. What does that tell us? And that's a significant effect. That tells us that kids who had bigger vocabularies at 1.5 years tend to also have larger vocabularies at 2 years of age. And that's statistically significant association. Now this paired samples t-test tells us something very different from the correlation. It tells us, okay, we know that if you have a bigger vocabulary at 18 months, you tend to have a bigger vocabulary at 24 months. But is your vocabulary at 18 months different than your vocabulary at 24 months? And so this is given to us by these test statistics on this side. You get a lot of other information too, but we will just go with this, okay? And what this t-test compares is this 13.42 to this 15.47. Note that the difference between these two numbers amounts to negative 45.05. So another way to think about this would be to take this difference score and compare it to 0. I'll show you that right now, actually. So I'm going to compute 24-month to 18-month difference score. So I'm going to take this number, I'm going to subtract vocabulary at 18 months, so vocabulary at 2 years minus vocabulary at 1.5. It doesn't like that I have a number for my name of this variable, so add the score difference there. So what this does in your database is it creates this difference score for us. So this subtracted for subtract this for each person. And I'm going to just show you that you can do a compare means with a one sample t-test on that difference. We're going to compare it to 0. And lo and behold, 45.05, this is the test statistic that we were just looking at for the paired sample, which come back to. And then we can also, instead of doing that, we can just compare the difference score between 18 months and 14 months and compare that difference score to 0. So is there a change? Because 0 would mean that there was no change. There was no increase and there was no decrease. And we see that the test statistic is exactly the same. The only difference is that this is negative and this is not negative. But the only reason why this one is negative is because of the way we coded. So if we had coded females 1, or not females 1, if we had put these variables in as in the paired sample as 24 and then 18, it should throw a different result. So let me reset this. So I'm going to compare 24 months with 18 months, which is the same thing as comparing 18 months with 24 months, except for in the reverse order. And we'll see that this t-test is exactly the same across all of these. So that just has to do with the order. Okay? So what we're going to write this up. So I just wanted to tell you about this, so maybe it gives you a little bit more conceptual handle on what we're exactly testing with this paired sample t-test. Okay, so I'm going to write up this paired samples t-test here. We compared kids' vocabulary at 18 and 24 months of age and found that kids had a significantly larger vocabulary at 24 months compared to 18 months of age. Okay. Then we would type in this test statistics. So space, italicized T, degrees of freedom is 59 in this test actually. So it's different. It's N, so we have 60 participants, N minus 1. So here, negative 24.41 is how we would round that. And in this case, we have another case of P is being reported in this table as a 0, so I'm going to type P is less than 0.01. And then we need to say what those means are. Okay, so we're going to say, go up here so that I can see those means as I type them up. I'm going to just lay this, okay. I guess I will go this way. Whereas at 18 months old, let's think about how I want to do this. So there could be different ways that we do this, and we can actually, I just want to show you another example. So one thing we can do is we can just have one sentence. We compared kids' vocabulary at 18 months and 24 months of age and found that kids had significantly larger vocabulary at 24 months compared to 18 months of age. I'm going to delete this because it seems a little bit repetitive to me. And we can actually embed the means into the sentence. So we don't even have to have a second sentence, because this sentence, as I have it written here, is pretty self-explanatory. We don't need to be so repetitive. So here I'm going to type in the number of the average words. So that's taken from this table here. We do the same thing, space, italicize, SD equals 14.53. And then I'm going to go here and type in 13.42 equals 4.43. There. And that's how we will write that up. Okay, please, you might need to watch this a couple of times to understand what happened, especially slowing down and watching how exactly those tests were executed when you have to actually do your homework. But you have this as a reference, and if you have any questions, you can always feel free to ask me, as always.